Hi there, welcome to James Stewart's Calculus Early Transcendentals 9th edition. We're doing question number 9 today, and the instructions say to differentiate, so let's jump right into it. With this question here, basically you have to figure out what the question is asking you for, and basically it wants you to practice using your derivatives. So there are basically two derivatives that we need to know. One is that the derivative of sine is simply cos, and the derivative of cos is negative sine. And finally, the derivative of theta, you treat it just like you would x, and it's just equal to 1. Okay, so let's jump right in. So I'm going to put the derivative rules on the left in case you need them for reference here. And now I'm going to basically point out that there is a multiplication here. What's in the brackets is being multiplied by sine theta, and there is a variable both in the brackets and outside the brackets, which is a hint you're going to have to use the power rule. So I'm going to start by taking the derivative of what is in the brackets, and with the sine theta left alone. And then I'm going to take the derivative of sine theta with what's in the brackets left alone. And that's basically just a power rule saying that you take the derivative of one part at a time and you add the products together. And so the derivative of the first term is pretty simple. The derivative of theta is just 1, and the derivative of cos is negative sine, but there's a negative in front, so negative times negative, of course, gives you a positive sign. And with the second term, the derivative of sine is simply cos, so it's just cos theta times what's in the brackets. And here I'm just doing a little bit of cleaning up. All that I'm doing is I'm taking that sine theta and I'm multiplying it into the brackets. You end up with a sine theta plus sine theta squared, and that cos theta, I'm multiplying it into the brackets. You end up with a theta cos theta and a negative cos squared theta. And then I'm just rearranging stuff a little bit so the squareds are in front and the regular signs of coses are in the back. You don't really have to do this, it just makes it look nicer, but technically both answers are the same. Now, the part that I really like about calculus, though, is that because it's internally consistent rules, there's multiple ways you could do this and you're still going to get the same results. So another approach is to distribute that sine theta in first. So if I take that sine theta and I multiply it by theta and cos theta, I can basically get two expressions here. But because I have two expressions where you both have the variable being multiplied, I'm going to have to use the power rule twice here. So with the first term, I'm going to take the derivative of the sine theta with theta left alone, and then I'm going to leave the sine theta alone and take the derivative of just theta. And with the second two terms, I'm going to take the derivative of sine with cos left alone, the negative cos left alone, and the other one, I'm going to leave the negative sine alone, and I'm going to take the derivative of the cos theta. This one I find is a harder method because there's a lot of signs where you could potentially mess up, but going on to the next step, it's pretty easy, because the derivative of sine is just cos, so that's all that happens in the first term. The derivative of theta is just 1, so that's all that really happens in the second term. The derivative of sine theta, once again, is cos, that's all that happens in that third term. And finally, the derivative of cos theta is just negative sine. And at this point, I just basically multiply the things together where appropriate to kind of clean it up a little bit. And I move the sine squared in front. I probably should have done this in 2 steps here, but the negative sine theta times negative sine theta gives you a positive sine theta squared. The second term comes from the negative cos theta times cos theta, which is negative cos theta squared. The third term just comes from that sine 0 times 1, which is just sine theta. And then finally you have your theta cos theta. But if you look at this answer compared to the other method, they are identical. So if you distribute first and then you do the power rule twice, or you just do the power rule once, it doesn't matter. Either way, you're going to come up with the exact same answer, which I think is one of the cooler parts about calculus. So when you're doing this problem, just do whatever feels right for you. If you're looking for the solution to another problem, go ahead and leave the section number and the question number below, and I'll do my best to get around to solving it. Alternatively, if you have a problem from another textbook, my email address is in the description. You can send it, and please consider liking and subscribing because I'll be uploading more videos in the future. And have a great day. Bye.